welcome back. We're talking about problems I'm going to be showing you on Physics Classroom. We were just deriving this nightmare in the last video, but now we're going to go ahead and move on. And we're going to show you how we're using this formula. You see, this formula comes on up, and they tell us we have a mass on a spring system, yes? Mass on a spring system, it gives us a mass. And it gives us this equation. This equation, x equals the amplitude, meaning the largest displacement, times the cosine of omega times t. They told us that it is, on our formula sheet, a cosine 2 pi f t, but we're scholars, and we know that 2 pi f is the same as omega because you watched the entirety of the last video. I know this. The first problem, they're asking for the angular velocity. Well, sorry, they asked for the angular frequency, but guess what? Angular frequency and angular velocity, they are synonyms. I can't tell you how many of these synonyms that we have. We do have oodles and oodles, but they are on our formula sheet. Sorry, they are on our vocabulary quiz sheet. That's going to prepare us for the vocab quiz tomorrow. Right? There's that. So in this problem, they are just testing you. But they're really insulting your intelligence by asking you a silly question like this, because you already know. You already know this. B. What is the spring constant K of the spring? Well, if you know that omega, if you remember that omega is equal to the square root of K over M, which we went over in the last video, then all you have to do is in B, go on step number 2. Isolate K, square both sides. Mass times omega squared. Then we get K, if we plug things in, is equal to 100 grams times 4 radians per second squared. This is the thing. When it comes to K, it needs to be in kilograms. I just have to tell you that for right now. I'm sorry. We'll have a reason for that later, but you just have to put in kilograms. Grams is unacceptable. So that means that we end up getting 0.1 times 1.6 radians squared per second squared because we squared radians per second. And that gives us 1.6 kilograms per second squared. This is the same thing as newtons per meter. You just got to deal with it. They're telling you right here that this is the unit. These busters with these physics curricula, they're not thinking about it the same way I am. And you know what? That means that every now and then there are some things that you have to trust me on. I know I don't trust you, but you should probably trust me in the fact that, first of all, the standard unit of mass is kilograms, which is noted in the vocabulary, and the standard unit for spring constant is newtons per meter, but it will also come out as the same thing as kilograms per second squared. And this is going to come up a couple of times. That's how we get this. C. They're asking for the period of the system. Well, they don't tell you any of this. These formulas, you just kind of have to memorize them. I don't know. They don't tell you that much on the formula sheet. They don't, because they're devious, malicious. They're trying to harm you. And what I end up getting is that T is equal to 2 pi over omega. I remember that from my equation or from my vocabulary sheet that Mr. Adams got me. Oh, Mr. Adams, why don't you have a study guide for the test? I give you all this. I do so much for you. I'm moving on. And if we finish this out, easy money, cake. The next one, they're asking for the cyclic frequency. That is the next little tricky bit. What is the cyclic frequency? That's just F. That's just what we know as F. And that means it's because F is the cycles per second, not the angles per second, not the radians per second. It's not angular. It's cycles. It's cyclical. Cycles. What's the amplitude? Amplitude is the maximum displacement. Amplitude is the maximum. Amplitude is the extrema. So many synonyms. I'm sick of it. I'm cyclical of it. Amplitude's right in the equation. A. Boom. They ask for in centimeters. I give them in centimeters. Second type of problem that you'll see on Physics Classroom is dealing with these graphs. All right. They give you in red a position versus time graph, in blue a velocity versus time graph, and in green they give you a acceleration versus time graph. This is consistent with the rule maker that we saw, where we have at equilibrium, or sorry, not at equilibrium, at the extreme is where we release this system. So that's where it's going to start from. At the extreme, the velocity is at 0. So that's where the velocity is going to start from. And the acceleration is pointed towards the equilibrium, which means it's always going to be opposite of the displacement that is there. If I have a pendulum start off to the right, the acceleration will be to the left. If I have a pendulum that's over to the left, the acceleration will be to the right. It's always the opposite. In this problem, they're asking for the angular frequency. Now, angular frequency, synonyms for angular velocity. That was frustration. I'm sorry. Sorry I had to see that. You have to remember, this is from memory. Omega is equal to root k over m. That's from memory. Plug it in. I told you that mass is not in grams, it's in kilograms. I told you. And there we go. It resolves itself. What's the period? Take a look at my. I'm definitely putting those on there tomorrow. I'm putting a lot of that on there tomorrow. Tomorrow's vocab quiz is going to be ugly. Two pi over omega is equal to the period. We have omega from the previous problem. Look at how the radians cancel out. 2 pi radians per revolution is the conversion that you're getting, because I told you last time that to go from omega to frequency is just going from radians per second to revolutions or cycles per second. It's a unit conversion. That's it. Now, which dotted line goes through the time where one full cycle has been reached? Well, it's when we go from one extreme to back to the original extreme, right? Because there are two extremes that we could be going through. We have the extreme that's going over here. We have the extreme that's going over here, but we are not worried about the extreme that's going over here. We're willing to go back around the full circle, because remember, this whole thing can be represented not just as half a circle, but a full circle. That's one cycle. D. Last problem. Here's my little truncated version of how to do comparison problems. Start off with the formula. They say that the spring constant has changed by a factor of 2.05. They're asking what's going to happen to the angular frequency. Angular frequency. Synonyms! Angular frequency is like angular velocity, omega. And so we have omega 2 over omega 1. We still have a ratio. You got to do a ratio. You can't get out of that. But K over M, I'm putting K2 over K1. M2 over M1. I know that these two, they're the same. M didn't change. They told me the mass is, well, they just didn't say the mass changed. They just said that the spring constant changed by a factor of 2.05. These turn into 2.05. So that means that this omega 2 is greater than omega 1 by a factor of 2.05. I'm done. How much time has been on the video? I can't see. It won't even let me show me. It's okay. It's far away. This is going to get uploaded. Y'all got homework tonight. You already know it. That's why you're here. I'm going to click stop recording.